In this video, we are going to summarize solving quadratic equations. So first thing, can you determine the roots of a quadratic equation by rewriting the equation in factored form? In our first example, we're going to take the following quadratic equation and we're going to solve it by factoring. But the first step is to use an equivalent equation. And all that means is to rewrite your expression with 0 on one side. So our first step here is to expand and simplify the left side of this equation. So what we have is 6x squared minus x, which equals 3x plus 42. We're going to move everything over to the left side. And when we do that, we get 6x squared minus 4x minus 42 equals 0. Next, we need to solve by factoring. And remember, our first step is always to common factor. So if we take out the common factor of 2, I'm left with 3x squared minus 2x minus 21, and that all equals 0. So now we know for this expression we need two numbers that multiply to a times c. And if we take 3 times negative 21, that's negative 63, and that add to b, which is negative 2. And our two magic numbers are going to be negative 9 and 7. So we get 2 bracket 3x squared minus 9 x plus 7x minus 21, and that all equals 0. Remember, the negative 9 and 7 come from our magic numbers. Next, we need to common factor each grouping. So we take out a 3x from the first group, and that leaves me with x minus 3. And we take out a 7 from the second group, and that leaves me with x minus 3. Next step, common factor out the x minus 3 highlighted in green, and we're left with the 3x plus 7, and that all equals 0. Finally, take each of the factors and set them equal to 0, and then solve for x. So we end up with x equals 3 and x equals negative 7/3. Second thing, can you determine the roots of a quadratic equation using the quadratic formula? So same as above, we're going to use an equivalent expression. So we have 5x squared minus 1 equals 3x squared plus 4x. If we move everything to the left side, I'm going to get 2x squared minus 4x minus 1 equals 0. Remember, our quadratic formula is x equals negative b plus or minus b squared minus 4ac over 2a, and the b squared minus 4ac is square rooted. So we can see from our equation that a equals 2, b equals negative 4, and c equals negative 1. So if we sub those into our equation, we get x equals the negative of negative 4 plus or minus negative 4 squared minus 4 times 2 times negative 1 all over 2 times 2. And if we simplify that, we get 4 plus or minus b squared minus 4ac in this example is equal to 24 all over 4. So that means we have first root is equal to 4 plus the root of 24 over 4, and the second root is equal to 4 minus the square root of 24 over 4. Using your calculator, you would get the first one to be equal to 2.225, and the second root to be equal to negative 0.225. And finally, can you determine the number of roots of a quadratic equation using the discriminant? So remember, the discriminant is just b squared minus 4ac, the stuff under the square root in the quadratic formula. So for this last example, we're going to use a discriminant to determine the number of real solutions for 9x squared minus 24x plus 16 equals 0. So again, there's our a, there's our b, and there's our c. So b squared minus 4ac is going to equal negative 24 squared minus 4 times 9 times 16. You type that into your calculator, you'll get b squared minus 4ac equals 0. And you should recall that since b squared minus 4ac equals 0, there is only one solution or root for this equation. And this means that if you had a graph of this parabola, it would be a parabola that opens up since the a value is positive, and it would only touch the x-axis at one point. So there is our one solution. Also, it's good to recall that if b squared minus 4ac was negative or less than 0, you would have had no solutions, so the graph would not cross the x-axis. And if b squared minus 4ac was greater than 0, that would have meant two solutions. That means it crossed the x-axis at 2 points. Again, there's some questions you can practice there at the bottom, pages 360, 1 and 11. And note for question 1, try to factor the equation if possible. There are some that will not be factorable, so you'll need the quadratic equation. For those that are factorable, please practice that method. And good luck.